Currently, we are passing through a pandemic situation caused by coronavirus. So, the word virus is very familiar to us. Today, I will talk about another one virus mediated disease which is very common and few of us I think already once infected with this disease. It is chickenpox. As a learner of chemistry subject, I will confine my discussion within the chemistry part of this disease, mainly the medication part. Keeping in mind the general audience, I have made it simple, easy to understand for all. Chickenpox, commonly known as Choti Mata in Indian rural area, is a highly contagious and airborne disease. It causes mild illness in both child and adults. This disease is medically known as varicella and it is caused by a virus named varicella zoster virus. The early common symptoms of chickenpox are fever, nausea, loss of appetite, aching muscle, headache. And usually these chickenpox start to form at the chest, back, and on the face, then spreads to the rest of the body. The symptoms begin within 10 to 21 days after the exposure to the virus. It causes the red rash, itchy spots, which turns into blister, fluid-filled blister. After that, it eventually scab over after maybe 10 to 15 days. So how does this virus spread? This virus mainly spreads through the physical contact. The varicella virus spread through the coughs and sneeze of an infected person. A chickenpox infected person mainly spreads the disease at the beginning 1 to 2 days before the first rash appear and 4 to 5 days thereafter. As already I told that this chickenpox it causes mild illness, but sometimes it causes severe brain damage like encephalitis, microcephaly, or it can even cause damage to the eyes, or it can create some neurological disorder. So we should be careful if we catch this virus anytime. So what are the medication available for this disease? The various antiviral drugs are used to treat the chickenpox infection. The most commonly used antiviral drug is acyclovir. The other two drugs are also used in the same family, ganciclovir and penciclovir, but these two are specifically used for the immunocompromised patient. So now I will discuss about the chemical structure of acyclovir. This is guanine base. This is naturally abundant and it is found in our body as one of the four nucleobase that is present in DNA and RNA. The main skeleton of acyclovir it contains one guanine base and one small side chain is attached to it. So here I have shown the synthetic procedure of acyclovir. Acyclovir can be synthesized starting from readily available ethylene glycol and guanine in short step with easily performable steps. So the cost of this medicine is not so high. I think acyclovir sold by GSK with the brand name Jobirex is cost 160 rupees for 5 tablets. So how does this virus works against how does acyclovir works against this virus? So actually inside the body the virus replicate and make many more of its copies. The virus use the enzyme DNA polymerase to assemble the individual component of DNA to make a large chain of viral DNA. So the counts of virus inside the body increases and we become more sick. Now the DNA polymerase it use the nucleoside guanine deoxyribose to make the viral DNA. What is the DNA polymerase does? It takes one by one guanine deoxyribose and attach one by one and make the viral DNA. Now please closely check the structure of the antiviral drug acyclovir and guanine deoxyribose. They are structurally similar, only the acyclovir skeleton it does not have the 3' OH group which is present in the guanine deoxyribose. Guanine deoxyribose, it contains 2 hydroxyl group, 3' hydroxyl group and 5' hydroxyl group, but acyclovir, it contains only 1 hydroxyl group, that is something like 5' OH group. This is the main structural difference between guanine deoxyribose and acyclovir. So first we will check how the viral DNA it forms. Actually, the enzyme DNA polymerase, it use the nucleotide guanine deoxyribose and it attach one by one to make the viral DNA. So here I have shown that here the DNA polymerase has taken one guanine deoxyribose and it is attached to another guanine deoxyribose in with the 3' hydroxyl group with the 5' hydroxyl group in a phosphate ester bond. So here another 3' hydroxyl group is vacant. So next the guanine deoxyribose, it will come and it will attach to the 3' hydroxyl group. So this viral elongation step, the chain elongation step, DNA elongation step, it will continue and it will form more and more virus. Now how the acyclovir works against this virus when we take this medicine? Already I have told you that the structure of acyclovir and guanine deoxyribose, they are very similar. So the DNA polymerase enzyme, it cannot differentiate among this acyclovir and guanine deoxyribose, and it try to attach guanine deoxyribose with the acyclovir, but when it comes to attach to the acyclovir, it cannot find the 3' hydroxyl group here. So the viral DNA chain elongation stops, which is the termination of the elongation step, that is the death of the virus and arrest of the disease. This is how acyclovir works against the virus. So quickly I will summarize today's class. First I have talked about what is chickenpox, how does it spread, symptoms and the adverse effects. Then I have talked about the structural features of antiviral drug acyclovir, and finally I have talked that how the acyclovir works against the disease. So thank you for your patience. Thank you all.